Hi, everyone. Today I'm going over chapter 1, which is just an introduction to nutrition for health, fitness, sports, performance. It's an introduction. We're going to lightly cover pretty much every topic we're going to go through in the next 10 weeks, but we're going to cover it lightly and just introduce. So, two major focal points of this book is the role nutrition, complemented by physical activity and exercise, may play in determining one's health status. Also, the role nutrition may play in the promotion of fitness and sports performance. 6 of the 10 leading causes of death are related to unhealthy eating and the lack of physical activity. Heart disease, cancer, stroke, Alzheimer's, diabetes, kidney disease. And every single one of them is preventable with a good diet and exercise. This is nothing you guys don't already know. A lot of this should be common sense for everyone. Genetics, family history also may predispose one to a chronic disease. The Human Genome Project identified various genes associated with many chronic diseases like certain cancers. Breast cancer, and prostate cancer can run in families in males and females. Diet and exercise may influence your genes. Epigenetics is a field of research involving the role of the epigenome. The epigenome is a multitude of specialized chemical compounds that influence the human genome by activating or deactivating DNA and subsequent genetic and cellular activity. I think this is an absolutely fascinating subject, so I'm going to show a short video because he explains it better than I can.
Imagine coming into the world with a person so like yourself that for a time you don't understand mirrors.
As a child, when I looked in the mirror, I'd say, "That's my sister." And my mother would say, "No, that's your reflection."
It's hardly surprising because you both come from the same egg. You have precisely the same genes. And you're literally clones, better known as identical twins. And yet, it's not uncommon for a twin like Anna Marie to get diagnosed with cancer, while the other, like Clotilde, doesn't. But how can two people so alike be so unalike? Well, these mice may hold a clue. Their DNA is as identical as Anna Marie and Clotilde's, despite the differences in their color and size. The human who studies them is Duke University's Randy Jirtle. So Randy, I see here you have skinny mice and fat mice. What have you done in this lab?
Well, these animals are actually genetically identical.
The fat ones and the skinny ones.
That's correct.
This gets even more mysterious when you realize that these identical mice both have a particular gene called agouti. But in the yellow mouse, it stays on all the time, causing obesity. So what accounts for the thin mouse? A tiny chemical tag of carbon and hydrogen called a methyl group has affixed to the agouti gene, shutting it down. Living creatures possess millions of tags like these. Some, like methyl groups, attach to genes directly, inhibiting their function. Other types grab the proteins, called histones, around which genes coil, and tighten or loosen them to control gene expression. Distinct methylation and histone patterns exist in every cell, constituting a sort of second genome, the epigenome.
Epigenetics literally translates into just meaning above the genome. So if you would think, for example, of the genome as being like a computer, the hardware of a computer, the epigenome would be like the software that tells the computer when to work, and how much.
In fact, it's the epigenome that tells our cells what sort of cells they should be. Skin, hair, heart. You see, all these cells have the same genes, but their epigenomes silence the unneeded ones to make cells different from one another. Epigenetic instructions pass on as cells divide, but they're not necessarily permanent. Researchers think they can change. And that brings us to the reason why we're showing you twins. In 2005, they participated in a groundbreaking study in Madrid. Its aim? To show just how identical epigenetically they are or aren't.
Our genes are just part of the story. Something has to regulate these genes. And part of the explanation is epigenetics.
Esteller wanted to see if the twins' epigenomes might account for their differences. To find out, he and his team collected cells from 40 pairs of identical twins, age 3 to 74. Then began the laborious process of dissolving the cells until all that was left were wispy strands of DNA, the master molecule that contains our genes. Next, researchers amplified fragments of the DNA until the genes themselves became detectable. Those that had been turned off epigenetically appear as dark pink bands on the gel. Now, the genes from a pair of twins are cut out and overlapped. The results are far from subtle, especially when you compare the epigenomes of two sets of twins that differ in age. Here on the left is the overlapped DNA of 6-year-old Javier and Carlos. The yellow indicates where their gene expression is identical. On the right is the DNA of 66-year-old Ana Marie and Clotilde. In contrast to the younger twins, hardly any yellow shines through. Their epigenomes have changed dramatically. The study suggests that as twins age, epigenetic differences accumulate, especially when their lifestyles differ.
One of the main findings of research is that epigenomes can change in function of what we eat, of what we smoke, of what we drink. And this is one of the key differences between epigenetics and genetics.
So that video is a few years old, but it shows a great background of what epigenetics is and how it can affect, especially with the mice, our nutrition. Way more strides have been made since this video came out. So there's a few vocabulary words to know as we go through the section. I won't go over these. You guys can read it in the book. Genomics is the main one we talk about. So preventing chronic disease, we talk about risk factors. A risk factor is a lifestyle behavior associated with any given disease. Cigarette smoking is a risk factor for lung cancer. Again, stuff you guys already know. I'm introducing these concepts because we go over them in the book more in depth, but this chapter is mainly about, hey, look, you know this stuff. Now we're going to jump off and dive into it deeper. Excessive alcohol consumption, poor dietary habits, physical inactivity are all risk factors for various diseases. To be successful at high levels of competition, actual athletes must possess certain biochemical, physiological, and psychological characteristics associated with success in any given sport. There are also certain genetic characteristics that can play a role as well. We just saw it with the epigenetics. They develop their genetic traits through proper biomechanical, physiological, and psychological training. They also receive proper nutrition through diet and sometimes supplementation. When we talk about physical fitness, it's a set of abilities an individual possesses to perform a specific type of physical activity. We talk about health-related fitness and sports-related fitness. Health-related fitness, a healthy body weight and body composition, cardiovascular and respiratory fitness, adequate muscular strength and endurance, sufficient flexibility. These are all things that humans need to have to be able to just basically live at a basic level. We also measure blood pressure, bone strength, postural control and balance, and then indicators of lipid and carbohydrate metabolism. All of these things we look at to see if a person is considered quote unquote healthy. And then sports-related fitness, we also Fitness athletes develop specific to their sport. Sometimes they need strength, sometimes they need power, sometimes they need speed, endurance, or neuromuscular motor skills. Compared to health-related fitness, training for sports performance is often more intense, prolonged, and frequent. Physical activity is any bodily movement caused by muscular contraction that results in energy expenditure. It's unstructured physical activity that we just do every day. Walking, cycling, climbing stairs, dancing, gardening, yard work. And then there's structured physical activity, which is a planned program of physical activities designed to improve fitness. Moderate to vigorous exercise, brisk walking, aerobics, playing basketball. Something beyond just what we do in daily life. There are quite a few basic principles of exercise training. There's a principle of overload. The basic principle of exercise training, intensity, duration, and frequency of exercise is going to affect how healthy we are. There's the principle of progression, gradual increase in overload with training. We gradually, if you're a weightlifter, you gradually lift heavier and heavier and heavier because once you get used to one weight, you got to go up to see any kind of progress. The principle of specificity, specific adaptations the body makes in response to a type of exercise and overload, specifically in your muscles. Principle of recuperation or recovery, periods of rest within an exercise session and between exercise sessions. Individuality, effect on exercise on each individual. That is the reduction in blood pressure for some, but not all, or the reduction in fat. Things like that. Principle of reversibility, disuse. You either use it or lose it. You use your muscles, you work out a lot, or you lose that muscle definition. Without exercise, the body will lose the adaptations it's made. Principle of overuse. Excessive exercise may induce adverse health effects. Shin splints, pulled muscles. Sedentary death syndrome is actually a term that is used. It was coined by that doctor, Frank Booth, at the University of Missouri. Him and his cohorts noticed that physical inactivity is a primary cause of most chronic diseases. Short-term cost, there's metabolic deterioration and weight gain. There's an intermediate term cost, increased risk for disease like type 2 diabetes. There are also long-term costs, like an increased rate for premature mortality or death. These are all benefits of regular physical activity. This is a picture in your book. You guys can read them all. I'm not going to. So how does exercise enhance health? Specific genetic mechanisms aren't completely understood, but we do know physical inactivity can cause genes to misexpress proteins, producing metabolic dysfunctions. And if our metabolism doesn't process all of our nutrients and minerals and everything the right way, problems pop up. Exercise will cause the expression of genes with favorable health effects. That's the whole epigenetics. Cytokines. Exercise stimulates the release of small proteins from muscle cells known as cytokines that will influence gene expression. Cytokines come from different kinds of cells. Muscles produce cytokines, a class of them called myokines. Fat or adipose tissue will produce a class of cytokines called adipokines. Cytokines and heat shock proteins produced by muscle cells may prevent chronic diseases when they are stimulated. This will increase the number of glucose receptors. It will improve insulin sensitivity and help regulate blood glucose and prevent type 2 diabetes. Local inflammation is recognized as a risk factor for several chronic diseases. Exercise produces anti-inflammatory cytokine to help cool inflammation and reduce health risks. Most marked improvements in the inflammatory profile are conferred with higher intensity exercise. So the higher the intensity of the exercise, the more cytokines will be produced. Combined aerobic and resistance exercise training may provide the greatest benefit. Other health-promoting mechanisms of exercise. The loss of excess body fat may reduce the production of cytokines that may impair health. The loss of excess body fat may reduce estrogen levels, which reduce the risk of breast cancer. The reduction of abdominal obesity may decrease blood pressure and serum lipid levels. Increased mechanical stress on bone with high impact exercise may stimulate increases in bone density. We need stronger bones as we get older because as everyone gets older, we run the risk of things like osteoporosis. But if we build up our bones now when we're young, the less likely we are to get osteoporosis when we're older. The production of some cytokines, such as brain-derived neurotrophic factor, may enhance neurogenesis and brain function, leading to a reduced risk of things like Alzheimer's disease. Key principles for developing physical activity programs. So there's a relationship between the amount of physical activity and health-related benefits. Again, we all know this. This isn't new information. There are no health benefits with a sedentary lifestyle. There are many benefits with moderate to high levels, but there are adverse effects associated with excessive amounts of exercise. There is such a thing as too much exercise. Components of physical activity plans. There is an individualization that needs to be considered when developing an activity plan. Exercise programs should be individually based on physical fitness level and health status. You don't want to make a person who's been sedentary their whole life all of a sudden go 100%. They're going to hurt themselves. Due to genes, physical activity may benefit some, but not others. Leisure time activity. It's recommended to reduce the amount of daily sedentary activity, sit less, move more. Aerobic exercise, muscle strengthening exercises, flexibility and balance exercises should all be included in a physical activity plan. All adults should engage in moderate intensity aerobic exercise, such as brisk walking for a minimum of 150 minutes per week, or about 30 minutes for 5 days. Alternatively, they may engage in vigorous intensity activities, such as jogging or running, for 75 minutes every week. So the more intensely you exercise, the less you can do it, the less you have to do it. Children and adolescents should do 60 minutes of moderate to vigorous exercise daily. We'll get into where we get our guidelines at the end, but these guidelines all come from somewhere. Aerobic exercise intensity is based on the MET, which is a term related to your metabolic rate. We're going to go over your metabolic rate in more detail in, I think it's chapter 3. But the talk test is easier. You're doing light intensity exercise if you can carry on a normal conversation while you're doing it. Moderate intensity is when you can talk but not sing because you're breathing a little bit harder. And then vigorous intensity exercises is when you cannot say more than a few words. Guidelines for muscle strengthening exercises. Adults should engage in muscle strengthening exercises on 2 or more days a week. Children and adolescents should do the same at least 3 days a week. You should work all major muscle groups: legs, hips, back, abdomen, chest, shoulders, arms. I know some people just like to do their arms. Some people just like to do their abs, but everybody should really be working on all of their muscles. 8 to 10 different exercises that stress these muscle groups. You don't have to do them every day. You can split them up throughout the week. And then 8 to 12 repetitions of each exercise at least twice a week or on non-consecutive days. Older adults may lift lighter weights or use less resistance, but do more repetition. Older adults should perform flexibility activities at least 2 days a week for 10 minutes. They should perform exercises that are designed to maintain the range of joint motion for daily activities and physical activity. Older adults should perform exercises that help maintain or improve balance about 3 times a week. Falling is a huge problem in the elder community. And when older people fall, they don't recover as quickly. So if when they are younger, or as they are getting older in middle age, they can do these exercises to improve their flexibility and balance, it reduces the risks of falls later in life. A little extra may be beneficial. Increasing the weekly exercise time appears to be associated with increased health benefits. An increase in the weekly amount of moderate intensity aerobic activity to 300 minutes or vigorous intensity about 150 minutes, or a combination of the two, Moderate physical activity for 75 minutes a week, such as brisk walking, was linked to an additional 1.8 years of life expectancy. Those who were active at least 450 minutes or 7.5 hours a week added 4.5 years. So the more you exercise, the healthier you are, the longer you live. Again, not something that you should be hearing for the first time. Are Americans meeting physical activity guidelines? No, we are not. Again, something we probably already know. 1 in 5 adults meets the recommendations of the 2018 physical activity guidelines. Those living in the South are less likely to be physically active. Non-Hispanic white adults are more likely to meet the recommendations than non-Hispanic Black adults and Hispanic adults. And those are just statistics. Am I exercising enough? I can tell you I am not. But there are a few ways that you can keep track. You can keep a daily record of physical activity, compare weekly totals with recommendations. There's also gadgets, Apple Watches. Every other person has an Apple Watch these days. You can use that to monitor and record daily levels of physical activity. You can also monitor things like heart rate, blood pressure. Can too much exercise be harmful to my health? Yes. Orthopedic problems, impaired immune functions, exercise-induced asthma, exercise addiction, osteoporosis. If you're not getting enough nutrients, but you're using a lot of them, that's going to cause problems. Heat illness, kidney failure, brain damage, heart attacks, and sudden death, accidents. Nutrition is the next section. Nutrition is the sum total of processes involved in the intake and utilization of food substances by living organisms, including ingestion, digestion, absorption, transport, and metabolism. We talk about every single one of those steps when we talk about nutrition. A nutrient is just a substance found in food that performs a function in the body. 6 major classes of essential nutrients: carbohydrates, fats or lipids, proteins, vitamins, minerals, water. The book has a chapter for each of these that we will be going over. Basic functions of nutrients in food: promote growth and development, provide energy, regulate metabolism. Every single nutrient does one or more of these things. The role of nutrition in health promotion. Food is medicine. They are promoters. They could also be promoters leading to the progression of chronic diseases, or anti-promoters. They deter the initiation or progression of chronic diseases. Good nutrition lowers the risk of them. Bad nutrition raises it. Health problems associated with poor dietary habits: stress, cataracts, alcohol, high blood pressure, lung cancer, heart disease, liver disease, diabetes, all kinds of cancers. Various nutrients and appropriate energy intake may promote good health. They may inactivate carcinogens. Carcinogens are those things that promote cancer or kill bacteria that damage DNA. They help repair the DNA. They increase insulin sensitivity, which decreases our risk of type 2 diabetes. They will relax our blood vessels and improve blood flow, which will reduce high blood pressure. Optimize serum lipid levels, reduce inflammation, inhibit blood clotting. We don't want clots in our blood normally, unless we actually cut ourselves, but enhanced immune system functions, prevent damaging oxidative processes, dilute harmful chemicals in the intestines, promote more frequent bowel movements. Do most Americans eat right? Again, the answer is no. On average, Americans of all ages consume too few vegetables, fruits, high fiber whole grains, low fat milk products, and seafood. And we also eat too much added sugars, solid fats, refined grains, and sodium. Not all of that is our fault. All of the processed foods have fancy and flashy commercials and ads everywhere. Eat this, eat this, eat this. It tastes good. You'll be happy. General guidelines for healthy eating comes from the Dietary Guidelines for American. MyPlate.gov is a website that we will be using. You guys are going to be analyzing your own diet for every single one of those macro and micronutrients, and then kind of synthesizing it at the end and seeing where you're at in your own diet. It's reviewed every 5 years. It should be reviewed here sometime this year. It is 2025, but we'll see with our government. A prudent, healthy diet in accordance with the total diet approach of the Academy of Nutrition and Dietetics and the various governmental and professional health organizations. Each specific dietary recommendation must convey some health benefit. So the more of these dietary guidelines you follow, the greater your overall health benefits should be. So every single nutrient, macro or micro, has a dietary guideline. You can follow one, but not the others. Not really going to help you. But the more of these guidelines that you follow, the healthier you're going to be. So balance the food you eat with physical activity. Eat a nutritionally adequate diet consisting of a wide variety of nutrient-rich foods. Eat more whole foods in their natural form. Eat fewer highly processed foods. That's an important one, especially for us. All of our food is processed. Choose a plant-rich diet with plenty of fruits and vegetables, whole grain products, and legumes, which are rich in complex carbohydrates, phytonutrients, fiber. Choose a diet moderate in fat, but low in saturated fat, trans fat, and cholesterol. Choose beverages and foods to moderate or reduce your intake of added sugars and highly refined carbohydrates. Choose and prepare foods with less salt and sodium. Maintain protein intake at a moderate yet adequate level, obtaining more of your daily protein from plant sources, complemented with smaller amounts of fish, chicken, and lean meat. Choose a diet adequate in calcium and iron. Women tend to have lower calcium and iron levels. Practice food safety, proper food storage, preservation, preparation. Consider the possible benefits and risks of food additives and dietary supplements. If you drink alcohol, moderation is the key. Enjoy your food. Eat what you like, but balance it within a healthy diet. The next section is about sports-related fitness. Athletes develop sports-related fitness by training for a specific sport. Strength and power are needed in football, bobsled, shot put, endurance, and long distance cycling, running, swimming, and neuromuscular skills are needed in gymnastics, archery, and cross-country skiing, and the biathlon. Muscle memory. They have to develop muscle memory. Gymnastics is a huge one. Elite athletes at the United States Olympic Training Center receive training focused on physical power, mental strength, and mechanical edge. If you are a professional athlete, or you want to be a professional athlete, you have to be well-rounded in all of these things. The application of nutrition principles to enhance sports performance, to promote good health, to promote adaptations to training, to recover quickly, to perform optimally during competition. That is from the Australian Institute of Sport as a definition of sports nutrition. Are athletes today receiving adequate nutrition? Results of this survey is mixed. Inadequate amounts of energy, particularly carbohydrates. High protein is always preached. Sometimes carbohydrates get forgotten about. Athletes consume more dietary fat than recommended, particularly saturated fats. Intake of vitamins and minerals varies. A lot of that has to do with supplementation. Athletes who restrict energy intake may be at high risk for micronutrient deficiencies. Iron and calcium deficiency may be common in female athletes. Females lose a lot of blood, so we need a little bit extra iron. Many athletes take dietary supplements designed to enhance performance. There are some athletes that are malnourished. Insufficient knowledge to make appropriate food choices. Misconceptions about the role of specific nutrients in sport performance, which we'll get to throughout the chapters. They may not be getting sound sports nutrition information. Websites. There are so many bad websites out there and poorly informed coaches that are using these websites. We're going to get to evaluating websites eventually. Financial constraints and time limitation for food preparation. Those Olympic athletes we were talking about, they do not get paid. So they either need a sponsor or they have to have a job. And having a job limits your time, that limits your time for food prep and training. And then financial constraints, that limits how many supplementation, how many coaches you can get, training time, all that stuff. It's amazing that these athletes can carry on as they do. Role of diet and nutrients in exercise. Of course, all of these things we already know. This is a picture from your book. You guys can look at it, read them all. What should athletes eat to help optimize their performance? Depends on a variety of factors: gender, age, body weight status, eating and lifestyle patterns, environment, and then the type of sport or events. So some athletes need endurance, some need more strength, some need both. There are varying viewpoints. Some say athletes need a nutritionally balanced diet like everyone else, and that no special recommendations are needed. Some say it's almost impossible to obtain all the nutrients the athlete requires from the normal daily intake of food, and for that reason, supplementation is necessary. Others advocate a compromise. Compromise is usually the key. Ergogenic aids, defined as a mean to increase potential for work output. Performing enhancing techniques, mechanical and psychological aids, but more commonly we talk about performance enhancing substances, physiological, pharmacological, and nutritional aids. Why are they so popular? They're easy: powders, pills, ready to drink products, nutrition bars, gels, sports energy drinks, shots. They are also very popular because they are marketed very, very well. So people want to believe in magical qualities of these supplements. Very shrewd advertising department. They're endorsed by professional athletes. They're recommended by coaches and fellow athletes. And the belief that sports supplements are natural, safe, and legal. Some of them are, some of them are not. Are they effective? Ergogenic aids are found in each nutrient class: carbohydrates, fatty acids, amino acids, vitamin B, special mineral supplements such as chromium, vanadium, boron, oxygenated waters, which I'm going to talk about in a second. Hundreds of non-essential substances or compounds: creatine, carnitine, coenzyme, inosine, all of those. They're all marketed as ergogenic aids. I'm going to talk about oxygenated water for a minute because it drives me crazy. So, water, H2O, that is the structural formula for water. Again, something you guys should already know. You've been in school for a while. That's what water looks like. Oxygen, in its natural state, oxygen is called a diatomic atom. It has to have two oxygen atoms together, and in its natural state, it is a gas. It is the air we breathe. It has to get very, 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 very below freezing cold to even become a liquid to mix it into water. Again, that is the structure of water. There's two H's and an O, H2O. You add an extra oxygen, it is no longer water. It is H2O2, which is hydrogen peroxide, which is that stuff that you buy at the pharmacy to clean your wounds or to clean something else. Hydrogen peroxide is the best at killing chemicals, or I'm sorry, killing bacteria. I used to clean my whole house with it when my kids were young to kill all the bacteria. But you cannot stick extra oxygen in water. It is chemically not possible. But people market it and people sell it and people buy it. Are nutritional ergogenics effective? Supplementation with essential nutrients above and beyond the RDA, the recommended daily accommodations, is not necessary for the vast majority of well-nourished athletes that are following dietary guidelines. Consumption of specific nutrients above the RDA has not been shown to exert any effect on human physical activity or athletic performance. Many sports supplements sold on the market are labeled with various performance enhancement claims without any scientific evidence. These people have tried it in their own labs, but it has not been reviewed by anyone else in the scientific community or elsewhere. Majority of them are safe when taken as directed, but there are potential problems. Some of them contain chemicals linked to serious illness and death, particularly when taken in excess. Mislabeled and contain unlisted substances like stimulants or steroids. A lot of these supplement companies, they don't have to list every single thing that is in their product. They should, yes. They don't always. Younger athletes may think that, oh, if one is good, then 10 is better. I'm just going to take 10 of them. That leads to an overdose, especially when there's hidden chemicals in them. The use of pharmaceutical agents to enhance performance in sport has been prohibited by the governing bodies of most organized sports, also known as doping. Some dietary supplements are completely prohibited. Steroids is one. Everybody knows steroids is prohibited in professional athletic circles. And then stimulants such as ephedrine. In the late 90s, early 2000s, ephedra was all the rage to lose weight and enhance your performance. But it was causing things like heart attacks. And a Major League Baseball pitcher actually died from an ephedra-induced heart attack, and that's when they completely banned it. So it is not legal in the United States anymore. Contamination of sports supplements that may cause an athlete to fail a doping test is widespread. Up to 25% of sports supplements targeted for muscle building and marketed on the internet were contaminated with prohibited substances like steroids. And then misinformation. Increasing numbers of dietary supplements are marketed to enhance health and physical performance, but many of them have no legitimate basis. Nutrition and health misinformation results in the spread of claims that are not supported by well-controlled research studies, which we will talk about what that is in a minute. Nutrition and health misinformation is a big business. Americans spend almost $1.5 billion annually on dietary supplements and vitamins. That's why it's not going away, because they make too much money off of it. As with nutrition and health misinformation in general, hope and fear are the motivating factors underlying the use of nutritional supplements by athletes. They want to gain a competitive edge. Possible factors promoting health misinformation in sports: direct advertising in sports magazines and books, and on social media. There's a huge market. I mean, how many of you are on TikTok and you see all these things on the TikTok shop? Oh, these are great. These are great. These are great. Buy these, buy these, buy these, buy these. And young athletes, kids, are not well versed enough in marketing techniques that they think, oh, this is great. I'm going to get this. I'm going to try it. I'm going to overuse it. So how do I recognize? Some questions to ask. Does it promise quick improvement or health performance? Does it contain some magical ingredient? Is it marketed by popular personalities or sports stars? Does it exaggerate a single truth about an ingredient? Does it question the integrity of the scientific or medical establishment? Does the person or magazine who recommend it also sell it? Is the claim too good to be true? Cautions on using the internet. Everybody recommends caution. People throw caution to the wind when they think, oh, I want this magic pill that's going to make me lose weight and be a great athlete. But along with others, here's some major points. No one regulates information on the internet. Anyone can set up a homepage and claim anything. Websites like Wikipedia permit anyone to enter or modify the information presented. And search engines such as Google and Yahoo host paid advertisements that may contain biased information. The more money you spend, the higher you are going to be in the search engine. Compare the information you find on the internet with other resources. Always, always, always check your sources. We're going to do a discussion on that next week. Check the author's organization, credentials. Many so-called nutritionists and other health professionals make false claims on the internet. Be wary of websites advertising and selling products that claim to improve your health. Be cautious when using information found on bulletin boards or during chat sessions with others or anywhere else on social media. And don't believe everything you read. Research and evidence-based recommendations. Research in the past has identified nutrients in foods and determined their functions in the body. They have proven the application of exercise to enhance sports performance. Current research with foods and nutrients has found that health benefits of certain foods and forms of exercise and the performance-enhancing effect of just regular nutrients, leading to evidence-based recommendations. Epidemiological research or observational research study large populations to find relationships between two variables, for example, dietary fat and heart disease. They use retrospective techniques to compare diets of those that already have heart disease to a similar group of those without heart disease. Or they will use prospective techniques. They will study the diets of individuals without heart disease, and then they study them for years and years and years, and then they compare those who get heart disease with those who do not. These help scientists identify important relationships between nutritional practices and health. Experimental research is essential to establishing a cause and effect relationship. Randomized clinical trials or intervention studies is what you want to look for when researching these ergogenic aids. They usually involve a treatment group and a control or a placebo group, and again, they study cause and effect relationships. The independent variable affects the dependent variable. So the cause would be the diet, the effect would be the heart disease. They study everybody's diets, figure out who ends up with heart disease, where did they go wrong. Research on effective nutrition on sports performance. They're mostly laboratory studies. They have a very tight control of extra variables, how much they exercise, what is the temperature in the room when they exercise, things like that. They mimic the physiological demands of a specific sport, but few studies have actually investigated the effect of nutritional strategies on actual competitive sports performance. Why do we often hear contradictory advice? It's difficult to conduct nutritional research about health and athletic performance with human subjects. There are always unknown extra factors that may lead to an erroneous conclusion, and the media either exaggerates or oversimplifies things. We always have to consider the quality of the study, the credibility, peer-reviewed study or presentation at a meeting, comparison of findings to other studies. Findings need to be put in the proper context, and you always need to consider the funding sources. Who is paying for it? If a company is paying a specific group of researchers, it stands to reason that those researchers are going to want to come up with results that are going to keep the money people happy. If the money people aren't happy, they're going to shut down the research. That is one of the important things of government-funded research is scientists just run experiments, they get the results they get. They report on them, whether it's good, bad, or ugly. So what is the basis for the dietary recommendations in this book? Individual studies repeated by other scientists. That is the scientific method. You take these claims, you're a researcher, you want to test those claims that have come before you to see if you come up with the same results. If you do, great. That is just more evidence that that claim is true. If you don't, okay, that's interesting. Let's go back and study this. Reviews of randomized controlled trials and epidemiological studies. You want your work open to review, or real scientists do. Please review my work. Tell me where I went wrong. Meta-analysis of RCTs. We're going to talk about meta-analysis. There's a really good website to look at the meta-analysis, which is basically all of the studies you can find on heart disease compared into one and summarized. What do they all say? And then position statements and position stands on the American College of Sports Medicine, the Academy of Nutrition and Dietetics, organizations like that, trusted organizations that do their research, that employ real scientists. The science of human exercise and nutrition is not exact. No science is. There may be no absolute 100% proof that a particular nutritional practice will produce the desired effect, but the recommendations are usually sensible and tested, evidence-based. So it is likely to do some good and cause no harm, which should be everybody's motto, really. So how does this relate to me? Everybody is an individual. You have your own genes. You have your own individuality. Salt sensitivity is just an example. Some people taste salt really, really intensely. Some people don't taste it at all, so they oversalt their food. Those people should never cook together. Your body is the same way. There are high responders and low responders to the same standardized exercise training program. Some people respond a certain way to certain pharmaceuticals to drugs to medication. Some people metabolize it really fast, some people metabolize it slower. Everybody is different. Individuals should also consult a physician or other appropriate health professional for advice on taking any dietary supplement for health or performance purposes. Always consult some sort of health or medical professional. That is all for chapter 1. I will see you for chapter 2.